Another 2.1% of the data will fall between the second and third standard deviation points. 95.4 plus 4.2 equals 99.7%. So less than 0.3% of data will fall outside 3 standard deviations of the mean. That is 3 standard deviations left and 3 standard deviations right of the mean. Is that where 6 sigma comes from? No. 6 sigma refers to 6 standard deviations on either side of the mean. The theory behind 6 sigma is that less than 3.4 parts per million fall outside the specifications because the tolerances are set at 6 standard deviations outside the mean. So we continue the above curve, taking us to 99.99966% of the data falling within 6 standard deviations on either side of the mean. So, if we wanted to achieve 6 sigma production of our rods, and we knew that our tolerances had to be plus or minus 0.05 centimeters, our data would have to show a mean of 0.95 with a standard deviation of around 0.008 centimeters. PMI loves to throw in a few questions on means and standard deviations and 6 sigma. Don't be intimidated. These numerical questions, once you know the trick, are a welcome relief from the philosophical ones. Let's go through what you need to know. First, memorize 2 key numbers on this graph. 34.1% of the data is 1 standard deviation from the mean on either side, or 68.3%. And 95.4% of the data is within 2 standard deviations of the mean. The PMP test will ask questions like this. Given a mean of 45 days and a standard deviation of 5 days, what percentage of the data will measure less than 50 days? For these questions, don't forget that 50% of the data always falls to one side of the mean. Thus, we already know the answer must be greater than 50%. But how much of the curve is represented by the numbers between 45 and 50? Remember that this area between the mean and 1 standard deviation outside the mean represents 34.1% of the data. Add this to the 50% to the left of the mean, and we get 84.1%. Answer C.